So here we are given with this VT graph, and we need to tell that as a function of time, does the speed of the particle, option A, is increases or it decreases, or it first decreases then increases. So we have to tell that which of these options are correct. And let me first discuss some important topics related to this question, and then at the end of the video we'll discuss this question. Welcome to STEM Professionals. In this video we'll discuss three topics. The first one is average acceleration. The next one, instantaneous acceleration. And finally, the graphical interpretation of acceleration. So let's start with the video. In the previous videos, we studied that velocity is the rate of change of position with time, or we can say it is the rate of change of displacement with time. Now the next step in describing the motion of a particle is to consider that how the velocity is changing with respect to time. And this leads to a birth of new physical term which we call acceleration. So acceleration is one of the most important topics in physics. Newton, for example, showed that acceleration and force are directly related. And Galileo showed that freely falling bodies move with constant acceleration. So everywhere the term acceleration is coming. So you should have a complete understanding of the term acceleration. So what is acceleration? Acceleration is the rate of change of velocity with time, and whenever the object accelerates, its velocity changes. So in this video we'll discuss about the average acceleration, then instantaneous acceleration, and finally the graphical interpretation of acceleration. Graphical interpretation of acceleration. So we'll start with average acceleration. So average acceleration is defined as the change in velocity divided by the change in time. So let me write here, it is defined as change in velocity divided by change in time. And mathematically we write this way, that average acceleration is delta v over delta t, and delta v means vf minus vi. Vf is the final velocity, vi is the initial velocity, divided by the tf minus ti. Now if you see the unit for the average acceleration, now here delta v, the unit for delta v is meter per second. It's a velocity, velocity means meter per second, divided by time. Now time we have second, it's the SI unit, so that would be equals to meter per second squared. So the SI unit for the average acceleration is meter per second squared. Now acceleration has both magnitude and direction. So it have magnitude and direction. Thus it is a vector quantity. Now we see that average acceleration can be positive, it can be negative, or it can be zero. Now let's discuss the question based on average acceleration. So here we are given that the average acceleration of airplane is 2.19 meter per second squared during takeoff. Now if the airplane started at rest, how much time it will take for it to reach a speed of 174 miles per hour? Now it is given that airplane started at rest, that means initial velocity should be 0. So vi is 0, and average acceleration is given to be 2.19 meter per second squared. Now we need to find the time at which the speed reaches this much. So final velocity should become 174 miles per hour. Now from the definition of average acceleration, we can write that average acceleration is equals to Vf minus Vi divided by Tf minus Ti. Now initial time Ti is 0. Initially we can take the time to be 0. So this would be 0 here. Now the final velocity should be 174 miles per hour. So we can put it here. Now before putting the value, we see that here the unit conversion should be done, because this unit is given in SI unit, meter per second square. So here also this Vf should be converted into SI units. So let me first put the values. This is average acceleration is 2.19 meter per second squared. Now the final velocity is 174 miles per hour. Now we're going to use the concept that we studied in the unit conversion. So we know that 1 mile, it means 1609 meter, and in 1 hour we have 3600 seconds. Minus the initial velocity is 0, so we can neglect this. This is 0, no need to write. Divide by Tf. Tf we have to find. Now here we have only one variable, that is Tf. We can use our calculator to solve this, and the value of Tf from here comes out to be as 35.5 seconds. So in this much of time period, the velocity of the airplane will become 174 miles per hour. So this is the answer. Now next we can discuss instantaneous acceleration. Now the way we defined instantaneous velocity, in the similar fashion we can define instantaneous acceleration. So instantaneous acceleration is the acceleration at a given instant of time. And instantaneous acceleration is a vector just like the average acceleration, and its direction is given by its sign. Now when we say acceleration, it means instantaneous acceleration, and if we are talking about average acceleration, then specifically we have to say average acceleration. Now you should note one thing, that when acceleration is constant, then average acceleration and instantaneous acceleration are the same. So we can write then average acceleration and instantaneous acceleration are same. Now next we can discuss the graphical interpretation of acceleration. Now we can discuss the graphical interpretation of acceleration. So consider this VT graph and let's try to find out the average acceleration for the time interval t1 to t2. Now for that let us join these 2 points with a straight line. Now this would be delta t, the change in time, and this would be delta v. Now the slope of this line will be delta v over delta t. Now this ratio delta v over delta t is nothing but the average acceleration. So this is nothing but the average acceleration. So we can conclude that the slope of a line connecting 2 points on an v versus t plot is equals to the average acceleration during that time interval. Now next we can also find the instantaneous acceleration on by using this VT graph. Now instantaneous acceleration is defined for an instant. So let's this be the instant time t3, and we have to find the instantaneous acceleration at point 3, this one. Now in the earlier videos we studied that the instantaneous velocity at a given point is equals to the slope of the tangent line at that point on x versus t graph. Similarly, we can say that the instantaneous acceleration at a given time is equals to the slope of the tangent line at that point on v versus t graph. So simply we have to make a tangent line at this point. So let's make a tangent line. It would be something like that, and the slope of this tangent line will tell you the instantaneous acceleration. The slope would be equals to the instantaneous acceleration. And the slope of this line will tell you the average acceleration. Now let's consider one more VT graph, this one. Here acceleration is constant, the slope would tell you the acceleration, and this acceleration is constant. And if acceleration is constant, then we can say that instantaneous acceleration will be equals to the average acceleration, because this acceleration is constant. Now we can move we can get back to the question that I discussed in the starting of the video. So this was the question that I discussed in the starting of the video. Now we have discussed earlier that speed is the magnitude of velocity. Now if you see that velocity is decreasing from time interval t equals to 0 to t equals to 2. You can see here that at time t equals to 0, the velocity is 1 meter per second, and at time t equals to 0 it becomes 0. So the velocity is decreasing, so its magnitude would also decrease, that is the speed would decrease. So speed will decrease in the time interval 0 to 2. Now after 2 seconds the velocity is increasing, but in a negative direction, like at this point at time t equals to 2 it was 0. Now at time t equals to this 4 second, the velocity becomes -1. You can see here the velocity becomes -1 meter per second. So if you see the magnitude of the velocity would be 1 meter per second. So actually the speed has increased from 0 to 1. So we can say that the speed increases for time interval t greater than 2 seconds. So we can say that option C is correct, this one, that it first decreases, the speed first decreases and then increases. So this is all with this video, and in the next video we'll discuss some more concept related to acceleration, velocity and speed. So we'll meet in the next video. Thank you.